Hello again. Tonight we're going to talk about why it doesn't make sense to use a nuclear device to take out an asteroid that's not even coming for Earth. And even if it's at very low probability coming for the moon, there are many reasons why it just doesn't make sense, even if you could. So I've kind of hinted on this before, but apparently those in authority didn't get the message. So I'll repeat it, and for those people that are paying attention. And the video will be posted. Prior video was probably too long. They need something with a clever clickbaity title that's under 30 minutes. So we'll try and keep that. So I'm sure you're familiar with the old adage of when all you have is a hammer, everything screw looks like a nail, even if you own a screwdriver. So I mean, you can certainly use a hammer to slam in a screw, but the screw will likely be loose, not firmly threaded into the hole. To do so just kind of confirms your laziness to not go get the screwdriver, as well as your ignorance of the side effects of doing what you do. Well, nuking the celestial body is pretty much the same thing. It just kind of confirms, the fact that you're not willing to look at alternatives. You're not realizing that probably not going to be the solution you expect. And then there's another adage, which is, you can whack a flea with a sledgehammer, but it's not really a demonstration of your superior intelligence. It confirms that you have aggressive tendencies and you don't really understand your tools and your target. It just irritates the flea, so to speak, until it's dead. The flea has no ability to recognize your superior might, nor does it have the ability to provide you probably the respect you seek for your ability to use excessive force. What you fail to realize is there's a lot more fleas out there, and maybe you need a more comprehensive and effective long-term solution. If you're using a nuke to destroy a celestial body like an asteroid, kind of along the same lines, it's not really a demonstration of your superior intelligence just because you can make a nuke, not your technical ability, like you can put it on a rocket and get it out to something out in space, nor does it show that you have any wisdom behind what you're doing. It confirms your aggressive tendencies and your ignorance as to your tools and the target you're attempting to take out. There are a lot of celestial bodies out there that may find their way towards the Earth-Moon system. And so you can take it out with a nuke if it's smaller, but there's nobody on it that's going to show you any respect for doing what you did. If that's your solution, that's not going to be effective when a meteor shower comes at us and we need to defend from that, because you won't be able to launch a lot of big nukes as fast. But what are these things made out of? Celestial bodies, particularly asteroids, meteors, and comets. They can be made up from a number of things. And we originally thought that they were going to be made out of, large stones, a very solid thing held together, and maybe have some metals in them like iron or some rare earth metals in smaller quantities, but a combination of all these things, and it's big solid stuff. But as we started to take, direct sampling evidence and do radar analysis and get pictures of them, we found out that these things, for the most part, at least not the ones that are big planet-sized ones, they're essentially rubble piles. They're things that are held together basically by static electricity and collective gravity. And if you hit them with something like we did a few years ago, it'll make a giant splash of very small to medium-sized things that go off in all directions, and you don't have any control over where they're going to go or where they're going to wind up. Before you decide to blow something up or smack it with something, know more about what you're attempting to target. So as I was saying, there's the postulation versus the evidence of, are these things solid? Do they have metals in them? Is it something we can easily take out? Or is it a rubble pile? Strangely enough, a rubble pile can have sufficient collective mass to compress itself into a spherical shape, which is one of the categories for saying that celestial body is on its way to becoming a dwarf planet or a planet, because it's big enough, it has enough mass that gravity will pull it into a spherical shape. But if it's a rubble pile, it's not a solid. It's not creating sedimentary layers or having molten rock that will then cool down and solidify. It's still just a rubble pile. And if you smack it with something, the debris field is going to be large and it's going to go off in all directions until that debris encounters some other large gravitational body, like another asteroid, or a comet, or a planet, or a moon. So we did this and found out that the rubble that was created from the rubble pile went off in all directions, and we started tracking not the smallest ones, because the smallest ones are micrometeoroid type, very small. They started tracking the larger ones. They were 100 feet across or so. And they found out that some of these things are headed for Mars. Not soon, but maybe years from now. But they're definitely on a target course for Mars, the moon, and potentially the Earth. Not directly, but indirectly. The ones that might hit the moon might actually hit the moon and kick off debris that could do exactly what they're saying they need this nuke for, to prevent Earth orbiting satellites from being damaged by debris caused from something hitting the moon. If that's the problem you want to solve, you're creating the problem you want to solve. But I understand the value of Earth orbiting satellites. It's a multi-billion-dollar existing asset for all the nations and corporations on the Earth. Maybe think twice before nuking a rubble pile. And then I thought, well, what is it actually that we're doing with this nuke, or with our ability? Maybe we're showing off that we can build a nuke that is big enough, with a big enough rocket to dispose of this inbound asteroid. Shows off our prowess as a nuclear power, that we can do this, because, well, as far as we know, nobody's living on this asteroid. There's no life on it. So it's kind of a disposable target. So if we show we can build a big enough nuke to take out a 500-foot sized asteroid, even if it's a rubble pile, what's the old mafioso saying is that, now imagine if you tick this off, that could be one of your industrial centers or one of your major cities. It would be a shame if something should happen to it. So be nice to us, do what we want to do, or we'll take that nuke that we destroyed an asteroid with and target it elsewhere. Not really demonstrating our prowess with nuclear devices, because we've already done that. We've already shown that we can build even much smaller nukes and destroy populated cities and industrial sites. That's already in the books. We don't need to demonstrate it again. Don't need to build an even bigger one to demonstrate we can blow up an entire asteroid. It just doesn't make sense to do it. But maybe it's good business for the guys building the nukes, the guys refining the plutonium needed for the hydrogen bomb in space, or the guys building the rockets to get the even heavier bomb that far out into space quickly. The thing to think about, though, is if you use a device that explodes using a one-time use rocket to get it there, it's one-time use. If you find you have to take out another one in the future, oh boy, more billions. Just pay for another one if you need another one, because they're not reusable. The bomb goes boom, the rockets go out there, maybe goes boom with the bomb, and you got to build another bomb. You got to refine some more plutonium. You got to build another big rocket. The thing to think about here is, whatever you're going to do, it has to be 100% successful. As in, if you build a rocket with a large device on it and the rocket blows up as it's attempting to leave Earth orbit, that's debris in Earth orbit, which could take out satellites, could create a radiation field. Not a good thing. And let's say you get it out beyond the Earth's atmosphere, and then the upper stage of the rocket doesn't fire successfully, and you can't actually get to the target or get to the target in time. You're not going to take out your target. What's the side effect? The side effect is whatever it was before you did nothing. Must be good business, but maybe there's a different way of, in the long term, having not so much good business up front or recurring big chunks of business, but better long-term business. So maybe people just haven't studied the history of using nukes in space. Back in the day, we said, nuking things above ground or at sea level is not a good thing for fallout, because fallout doesn't know any boundaries of countries and can traverse the entire planet and raise cancer rates. So we decided, let's stop with the nuclear testing above ground, or, in the sky, in aerospace. That was before they went to nukes underground. And they said, let's detonate them in Earth orbit. What they found out was detonating them in Earth orbit, not good for the overall fallout across the whole planet. A little material called radioactive cesium. It can spike cancer rates world over. Not good. So internationally, even with the guys we think of as enemies, we came up with this international agreement. Let's not put nukes in space. Let's not test nukes in space, except at times of war, then all bets are off. So if we go to detonate a rubble pile that's on its way to the moon, and we detonate it in the Earth-Moon system, then that radioactive ash from vaporizing the rubble pile and the radioactive particles of fallout, those are going to go in all directions, including back towards Earth for an extended period of time, maybe years. So, some of that ash might burn up during reentry, but if it's large enough, it might create its own radiation belt, like the Van Allen belt, around the Earth, and that would make it difficult for higher altitude satellites and for leaving Earth orbit. Or it may enhance the radiation of the existing Van Allen belts, and that could take out satellites. And the nuclear detonation itself, if close enough to the Earth, could create an electromagnetic pulse that could also take out satellites. If the satellites are what you want to save, here's another indication of maybe it's not the right way to do it. So I wouldn't just be negative on everything they want to do without coming up with a proposed alternative. Maybe put into super geostationary Earth orbit one or more kilowatt to megawatt class solar powered high energy particle beam satellites. Now, super geostationary just means that it's higher than geostationary. If you're a geostationary or geosynchronous orbit, then the place where you are in orbit rotates in synchronicity with the Earth rotating. So it stays over the same spot above Earth 24 hours a day. If you go super geosynchronous, the Earth is rotating underneath the satellite, and the satellite can actually stay on target in space longer than a 24-hour period. So you get more time on target. The satellites that we have in lower Earth orbit, like the Hubble Space Telescope and others, they're in low Earth orbit. So they go orbit the Earth about every 90 minutes. So in the course of a 24-hour day, they can't get a full 24 hours of single exposure on a target, 24 hours of time on target. They get about 90 minutes and then go around the far side and then come back out, open up the shutter again, get another 90 minutes. If you want to have more time on target, put it in super geostationary where you can actually point it at something and the Earth will rotate underneath you and you can keep the beam on target for a longer period of time. Now, obviously, these things will be pointing away from Earth into space. If you put enough of them in super geostationary orbit, they can be pointing pretty much anywhere in space. Essentially, the particle beam is not going to vaporize or detonate the target. It's going to act as transferring particle momentum to the target, kind of like a repulsor ray from Star Trek. It's just going to very slowly push against the target using radiation reflection pressure on the target. If you've ever studied reflection pressure from photons, the wavelength of the photon, the increasing wavelength of the photon decreases the amount of momentum you can transfer to whatever it reflects off of. So if you want the highest amount of momentum transferred to the target you want to push on, don't use infrared or visible. Move up to ultraviolet or X-ray. Remember, pointing away from the Earth, and it's above the Earth's atmosphere, so there's not going to be a lot of Earth atmosphere getting in the way of the power you're sending out. Remember, the goal is not to destroy the target or vaporize it. It's just to, for a long period of time, for extended exposure, push on it. A small amount over a long period of time. If you want to nuke something, it may take us a long time to build the rocket, build the nuke, and then launch it and get it there. But a beam of particles that's basically photons, it travels at the speed of light, and it will be moving away from Earth as soon as we can put them in orbit. As the target gets closer to the Earth, people might say, well, the beam will be dispersed the farther away the target is. And that's correct. But as the target gets closer to us, the beam will increase its momentum transfer because the beam will be narrower. Another thing about having a network of these satellites is they're reusable. Point at a target, send out the beam. Once you've changed its trajectory away from the Earth, you turn off the beam. You find another target, turn the beam back on. Do it. It's solar powered, not nuclear powered, solar powered. The only thing it's going to run out of over time is its orbital maneuvering fuel. It can rotate using gyroscopic inertial momentum and position itself that way. But if it has to slip its orbit or raise its orbit, then it actually uses fuel to do that. Even if it's ion propulsion, you have a fixed amount of fuel when you launch the satellite. So until we solve that problem, a ring of these satellites not only offers us collectively an ability to have multiple of them target a single destination celestial object, but also if any of them fail, you have redundancy, you have backups. Because we already have the ability to place multi-ton, multi-kilowatt solar-powered satellites in superior Earth orbit, we don't have to build any new kinds of rockets, and we don't have to make any nukes, no more plutonium to do it. we already have the high energy UV lasers and X-ray lasers that we use for making things like the highest density computer chip. We have the rocket technology. We have the laser technology. We can put things in high orbit. We've got a lot of what we already need. And because it travels at the speed of light, it won't take the snail pace time of rockets to get there. If we find a target that's coming in from the sun, and those do happen, and we only have a few days notice, we can turn to a bunch of these satellites once they're up there and push on it just enough to make it pass between the Earth and the moon instead of hitting the Earth and the moon. But if industry wants to make billions in continuing revenue, then they can convince governments to build these devices and launch them into super geostationary orbit as soon as possible. No time like the present, but we already have the technology for the satellites, the technology for the lasers, and the technology for the rockets. A Falcon Heavy can put things in geostationary orbit easily. Well, it puts it in a geostationary transfer orbit. It's actually the third stage that puts it into its final geostationary orbit. So we have the technology, as the saying goes. We can put lots of them in orbit as soon as possible. We can put a demonstrator in orbit even sooner, and over time we can improve them. We do that with weather satellites, and as long as we have a pipeline of, we've always got not only the current ones, but we've got the replacement for each one of those should they fail or run out of fuel. So if you put 100 of these things in a ring at equatorial orbit, then you can launch another 100 of them that are sitting in wait right behind those, that if they fail or if you need a backup, you've got them. You can launch additional ones over time. So you have the current ones and you have their backup. When the current one goes out, then you have the backup come in and you launch a next technology improved generation of it. And we do this with weather satellites all the time. The GOES weather satellites, there is always the current one and its backup. And when the current one has a problem, we shove that into a parking orbit over the Pacific. And then the replacement goes back to east or west of the US. And now it's the current one. And then we look forward to launching the next generation one as soon as we can get it up there to have its replacement. We can do, we already know how to do that. That's something we can do. So in summary, we can use existing and developing technologies for a long-term solution that will work either on single targets or collectively against a shower of these targets. We just have to deploy high Earth orbiting ring of satellites that have UV or X-ray particle beams that are solar powered, and they can just, over a long period of time, push to change the trajectory of targets, maybe decades before they ever get anywhere near us. Or we can use nukes and show off our technological ignorance. And then after we misfire and we can't take it out, sorry. If a nuke is not 100% assured, which is what is required for planetary defense, they're expensive. We're going to require a gigaton yield where we already have just megatons. And then we're going to require newer, bigger rockets. And how do we put multiple of them up there to be at the ready? We have to leave them in orbit. If we don't do it right and we can't get it there soon enough, then how do you save Earth before it gets smacked by something? I'd say deploy particle beam pusher satellite network as soon as possible. And, failing that, nukes are always a plan B if you really want them. And then the asteroid they're talking about is 2024 YR4. And then there are prior discussions of how you would go about nuking an asteroid. And then if you think about nuking things in space, the hazards of fallout, and then what a rubble pile asteroid is and why we're finding out some things that we thought were solid rock are actually just rubble piles and the of smacking it with something. And then if you want to know about how you stage over time the geostationary weather satellites, there's information on GOES. Okay, comments, questions?
Very interesting. And aren't they going to want to test this new gigaton nuclear device? And where are they going to test it?
They're not going to test it. They're going to computer simulate it because we don't have any place on Earth that anybody would want to detonate it, either underground, on the ground, in air, or in orbit. Nobody wants to detonate a gigaton device because the fallout from it would be horrific. And if you remember the history, when they detonated the first Los Alamos nuclear device, there was a greater than zero probability they would ignite the Earth's atmosphere.
Yeah.
And the Russians detonated the largest above surface nuclear device, and it scared them into not ever detonating anything that big ever again. So if it scared them from even testing such large devices, and the US has never built something that large, if something is more than 1,000 times larger than the largest thing we ever frightened ourselves by detonating, there's only one place you're going to detonate it. You're going to find some asteroid closer in, build the bomb, which means making a lot of pounds of plutonium, and then putting it in a warhead with all the appropriate electronics on board a rocket whose third stage had enough forceful propulsion, not ion drive. And we're talking about forceful propulsion to get it to the target as soon as possible. If you remember, the second most powerful rocket ever launched from the Earth was the one we used to put the New Horizons craft on its way to Pluto. And it took 10 years to get there. That was the fastest thing we ever launched from the Earth. So space be big, our rockets be anemic.
Computer testing is all well and good, and it may be terrific for initial testing. And,
Yes.
but if we're depending on this thing to possibly save the Earth or a large chunk of the Earth, I don't know if I want to trust it to 100% computer testing.
We actually have, as part of our annual federal budget, funding for Sandia National Labs out in the Southwest US to do computer simulations on optimal and more optimal nuclear detonations for smaller and smaller physical warheads with more and more punch and reduced radioactive fallout. So we've been doing simulations for quite some time to avoid us doing any actual detonation testing.
Isn't our nuclear arsenal also tested via computer, which I never quite understood?
No, that's just testing out the electronics.
Oh,
yeah,
that makes sense.
Yeah, that's just because the electronics, most people don't know this, but being a computer person, I've studied it. When we were making electronics where the features of the integrated circuits were at the 50 nanometer and larger size, way back in the day of like 6502 microprocessors and such, there's something called electron migration that wasn't a problem. That as we built things that had 20 nanometer and smaller features in the integrated circuits, the electrons that are used to power the semiconductor gates can actually penetrate the part that's supposed to be the semiconductor. So the electrons can actually leak through the part that they're not supposed to leak through to because of electron migration. As we're making our weapons with more advanced electronics, we've already crossed that threshold. So we have to periodically make sure the electronics are working as expected so that they're reliable, so that you have enough electrons getting to the threshold where the binary gate actually flips rather than nothing happening. So yeah, we do electronics testing of our warheads without launching the rockets, without even actually firing up the rockets, and certainly without detonating anything.
Thank you, Monroe. This has always puzzled me. I mean, for much of my life, I wondered, how are they testing these things with a computer? Don't they need to actually blow up something once in a while? But that makes perfect logical sense that they test the electronics.
When they're actually testing, and they have built newer rocket systems for launching them for both ground-based and submarine-based. As they build improved models of the rockets, they launch them with not even explosive payloads, certainly not nuke payloads. They launch them with dummy mass equivalent payloads to see that the rocket actually functions as a rocket over the trajectory that they expect and has the carry distance, can travel the distance they expect them to do, the intercontinental distances. So yeah, we found ways to do everything except the actual detonation.
I'll bet you that unbeknownst to everybody, this civilization we're living in has blown up nukes out in space.
Oh, yeah, we have. Yeah,
so,
both the U.S. and Russia. I don't think China has, but both the U.S. and Russia detonated nuclear devices back when they were sub-megaton, back when they were the earliest of not fission, but fusion, back when we were playing with fusion for the first time, and we wanted a place to safely detonate them. But if we buried them underground, we didn't know how deep we would have to bury them, so we detonated them in orbit.
Right.
and the amount of fallout and ash affected the worldwide cancer cluster levels. And so very quickly, the governments of the world, including Russia and China and the US, decided we're going to have a ban on putting nukes in space and detonating nukes in space for testing purposes. However, if there's a nuclear war, all bets are yeah, we did scare ourselves a couple of times, but the real thing to point out is if you're attempting to defend the Earth from something that you know is going to cause a problem at a higher probability than 5% or 0%, you need 100% assurance it's going to perform as you expect. If you're building the biggest gigaton bomb you've ever built, what's your assurance it's going to work unless you actually launch one and you take out an asteroid and then you have a sample of one?
Yeah, or even if it's not at an asteroid, just shoot it way out somewhere, blast it off, and let's see what happens.
Well, you could shoot it towards the sun. I don't think the sun would care about the radiation because the sun's a much bigger nuclear fusion engine than is anything us puny humans could have created. If you need a 100% assurance that it's going to do what you want it to do, a nuke on a big rocket is not the way to go. Remember the early days of NASA? Every time they launched something, it would explode on the launch pad or it explode, 100 feet off the ground, where it wouldn't make it to orbit, it would explode. I mean, even the latest stuff from SpaceX, there's a probability it's not going to completely do everything it needs to do, and either it's going to explode or they're going to have to blow it up. Having a rocket carrying a nuclear warhead that may explode, it's going to fall back even if it doesn't detonate. You now have this very large mass of plutonium burning up into Earth orbit, creating a spherical envelope of plutonium. Not good. So there's just so many reasons why not the smart thing to do. And I've given them an alternate approach that they can start working on today. They can launch them today. They can test them out on pretty much anything that is small enough initially. And then when they prove it out that it can change its trajectory, then they can build more of them. They can build more powerful ones. And there's no nukes involved. If you put 100 of them in orbit, if you occasionally have an oops and one of them explodes, you've got 99. Launched another one. You've proven that you can launch them. SpaceX's Falcon Heavy technology is reusable rockets. The two side boosters come back and land on land. The central booster, if you want to go to geostationary orbit, that one they have to sacrifice. That one falls in the Pacific Ocean somewhere, burning up. You have multiple of them, redundancy. You can put multiple of them on the same target for increased effect. They're solar powered, not nuclear. There's just so much better than using nukes.
So what's the likelihood that they're going to utilize this instead of what they're doing?
Even if they were to watch the video that I publicly produce, I don't think it's going to change some of their minds, because remember, there's two reasons why they're going to do this, having nothing to do with is it going to save the Earth from an asteroid. Looky, we built the biggest bomb ever. Take that, foreign competitors. Okay, but the asteroid doesn't care how big a bomb you build. The other thing is, hey, look how big a bomb we can build. Would be a shame if we had to target your country with that. Scare tactic. And the other one is, hey, if we have to build the biggest bomb ever built, we need another kind of Manhattan project. So bada bing billions. And if we want to build the biggest rocket that has ever been built to get it out to deep space, bada bing billions, companies are going to want to influence decisions to, yeah, good idea. No, not a good idea. If you just think about it for a while, it should be more than just my individual opinion. Can't not make sense to a number of people. Okay, any other comments or questions before I stop recording? Hearing nothing.